All right, so welcome to it. I can't believe this is only our second time we've done this class, but such is the case of a Monday-only class in spring semester. You always have that Monday Martin Luther King Jr. day off, and then I just happen to be in tech. So anyway, we're back. I know that I didn't give you a whole ton of things to accomplish between the last class and this class, but some of the things you were supposed to accomplish was figuring out what kind of experience you wanted to have with your pointing device. So hopefully you've all sorted that out. If you haven't entirely sorted that out yet, you still have one more week before that's going to become important. The other thing you were supposed to do is just kind of practice zooming and panning around in AutoCAD drawing, just getting comfortable with that process. So does anybody have any questions about that process? I know it was not super complicated, but it is something you will do the most of in AutoCAD. The thing you do the most of in AutoCAD is zooming and panning. So that needs to become like, just second nature to you. You do not have to think about it. Okay. Nothing? Great. Well, let's start drawing then. So this is the assignment I'm going to give you to work on this week. And I'm showing this to you first, and then we'll start talking about how you might accomplish this. So you are going to need to draw, all of you will need to draw this collection of symbols from a sound system diagram. These are just kind of some of the generic symbols that we discussed last time. So you'll need to draw all of these, and then if you are a undergraduate student, aka a Cal or a Jess, you will also draw this. Okay. If you are a graduate student, aka a Jasmine, a Connor, or a Seth, you will draw this instead. Okay. And Cal I know always likes to challenge himself with the grad thing. So if you want, if Jess or Cal, if you really want to do this more complicated one, you're welcome to, but you don't have to. Okay. You don't get extra credit for doing the harder one, but if you want to do the harder one, you're welcome to. Okay. All right. But here's the catch. You have to draw this whole thing without your mouse. Which is why I said earlier the mouse is not super important until next week. So you can't really use your mouse to draw this thing. The only thing you can really use your mouse for is for panning and zooming and possibly selecting something if you make a mistake. If you make a mistake and you got to delete something, you might need to be able to select a line and erase it, but I'd like you to try to avoid having to do that. There are other ways to get around that kind of problem that I'll show you in a minute. But if you must, I'm okay with you using your mouse for that part. So let me now explain. So go ahead and launch AutoCAD. And when you launch AutoCAD, you will hopefully be presented with something that looks like this. Is this what everyone's seeing? Yeah? Okay. So this is a list of templates that comes with AutoCAD that mostly pull up tool sets that are appropriate for the different kinds of drawings. The one that you're going to use really all the time is this one called AutoCAD.dwt. This is just for a simple, generic, two-dimensional AutoCAD drawing, nothing fancy. We do not do fancy things with AutoCAD. Our drawings are relatively simple. But there are other things, like if you're going to do a three-dimensional drawing on AutoCAD, you would do the AutoCAD 3D. That actually just pulls up some of the toolbars for three-dimensional drawing and navigating, different things like that. But again, not super critical for what we're going to do. You're almost always going to use this AutoCAD DWT until you have your own template, which you will make in about a month or so, where you will have your own template file that you will always start from, that will have your stuff that you need to work efficiently. So for now, you're going to use the AutoCAD DWT. So just select that and click Open. And this is what should come up. It's just an empty drawing with some toolbars and stuff, okay? The first thing I need you to do, this is just to make sure that everything that happens from now on will be the same for all of us. We need to reset AutoCAD to all the default settings, okay? So if you've been goofing around with AutoCAD already and you've maybe customized some things, it's time to blow it back up again, and we're gonna start over, because I need you all to have exactly the same experience for the next few weeks. Otherwise, you will be confused, because I will say things like, oh, do this, and this will be the result. And it may not be the result if you've made changes to AutoCAD, because AutoCAD is very customizable, and you can get it to do things differently if you want to. So we're gonna go to this AutoCAD menu and say Reset AutoCAD. Okay? And then click Reset AutoCAD. And that's just gonna undo any customizations you may have already done, reset it to all the default preferences and toolbars and all that kind of stuff. And it'll relaunch, and then we'll be ready to go.
What am I doing wrong?
I don't know.
I put the login and I have AutoCAD in, but when I do I had it in my downloads, but I guess it's on my different computer, so it popped up. But I did the free trial thing. But
You don't need to do it here. It's already on here. You just open it on here.
Oh, that's what I do. I went to download.
So go to Applications. It's in here. Scroll down. Go to Autodesk and AutoCAD 2023. Yeah, it's already. If you want it on your own, you can install it here. But
That's doing the same thing we're doing on here, so I just do it on here.
yeah. No, so look, it's coming up.
Thank you.
Yep. All right. Okay, I have successfully rebooted. So let me know when everyone is back to this screen. Let me know when you're here, Jasmine. Okay. Everybody good? Okay. So let me get you the right spot here. Okay. Thank you for that. Let's open up. Okay, so it's gonna ask for permission to consult the Russian hackers before you do anything.
I leave everything as is.
Sure. I don't think there's anything the Russians need to be concerned about with your AutoCAD. So go to Create and click that AutoCAD DWT right here. Click Open. All right.
Great. Thank you.
Okay, so yes, now you can reopen the AutoCAD.dwt. And we're back. Now you should see exactly this. Okay? Anybody not seeing exactly this? Okay. Excellent. So this is what AutoCAD 2023 looks like when it comes out of the Virtual Box. AutoCAD is a program that is as old as me. And when it was first created, computers existed, but they were not really like computers are today. Okay, they did have, for the most part, they did have like a monitor that you could see things on, and they had a keyboard you could type with, but they did not have like a mouse. That was not a thing. And the reason a mouse was not a thing is there was nothing to click on. There was no graphical interface for you to see. Things like menus and buttons and windows and icons, those did not exist. Everything was sort of like command line based. It was running what was called DOS, which was, a command line program that Bill Gates purchased. He didn't actually make it. He purchased from somebody else and then slapped Microsoft's name on it. So that was how AutoCAD originally ran. Because of that, they had to figure out how to deliver a tool that could do computer-aided drafting using that level of computer technology. And so it was all the only input device they had was this. Okay? This was the only tool they had to collect information from the user. And so they had to build a drafting program that would allow you to draw things using this keyboard. Okay? Later, they created what was called a digitizing tablet, which was, they basically made their own little input device. This was still before graphical user interfaces existed, but it was like a big kind of like, almost, it was very similar to like a Wacom tablet like this, but it had things like icons and buttons and stuff like printed on it, okay? And it had a thing like a mouse, okay, that had a little crosshair on the end of it. And you could kind of go over, and basically AutoCAD knew where things were on that tablet, and it knew where your little pointer device was on that tablet. So when you would go and hover your little crosshairs over something and click, it knew that you just clicked the command for something, line or whatever, right? And you could what you could do is you could take a drawing that you had done with a pencil, right? And you could, on a piece of paper, and you could lay that on that tablet and essentially trace it, okay? Using that digitizer device to issue these command line prompts for AutoCAD, okay? That was like step 2 in AutoCAD's development, all right? Then when graphical user interfaces became a thing, that like opened up a lot of possibilities. It was like, oh, okay, wow, we don't need the tablet anymore because we can actually just like put the picture in here and we could just click and stuff with the mouse. And that was like, changed everything. Not just for CAD, but computers in general. I mean, the graphic user interface was huge, major innovation that kind of opened up a whole lot of possibilities. And so from then on, what Autodesk has really done with this product is they've just constantly tweaked that graphical interface. They've tweaked kind of that experience of like what you see when you open it up and what's available for you to interact with, okay? And they change it really often. In fact, they've now moved to a subscription model with AutoCAD where you have to like pay them money every year to keep your license current. The upside to that is it's actually a lot cheaper. I mean, purchasing a license of AutoCAD used to be like thousands of dollars. And now, like, you can have AutoCAD for, hundreds of dollars a year instead of thousands of dollars that are theoretically perpetual license, but you're just until the operating system kind of like outgrows it and it doesn't work anymore and you have to buy it again. So the advantage here is, okay, well, you just spend a few $100s every year and you always have the latest version, and that's great. But they have to kind of justify paying for it all the time, and so they're always changing something. Every year a new version comes out, and they always tweak something so that they have some reason for it to be different and you to pay more money. And most of the time, what they're changing is they're changing this graphical interface, okay? So they're moving things around, or they're coming up with macros and stuff that can collapse multiple commands into one button, or rethinking certain windows that pop up and the layout of them and stuff like that. So they're just tweaking little things like that. But here's the really interesting thing. They have never, ever changed that original functionality of drafting with a keyboard. Like, that still works the same way as it always has. They've never changed it. And I am, well, you know now that you've been here for a little over a semester, you know that we are sort of shoveling very quickly a lot of information into you, right? At a very rapid pace, and trying to get you to retain as much of it as we can, okay? And we don't really have time to reteach you things, right? And you don't really have time to relearn things, because we're always throwing something new at you. And so I would like, if I'm going to teach you something, I want to teach you something that I'm pretty sure that if you can retain it, it is going to be useful to you forever, as far as I can tell. And so far, the part of AutoCAD that has never changed is command line. So I want to teach you that. And then over the course of the semester, we'll slowly kind of roll in some of these newer things that are cool and do make things easier. But I want to teach you that basic command line version of this, so that when you're confused and when you suddenly download AutoCAD 2026 or something, and it comes up and everything looks different, and you're like, oh crap, I don't have time to figure out what they've done differently here, you know that you can always just start typing and you'll be able to draw things, right? So, and I can't tell you how many times that has happened to me, where I install a new version of AutoCAD and it comes up, I'm like, what in the world have they done? I have tech tomorrow and I do not have time to relearn this. And I was like, I'm just gonna start doing command line, and just so I can get through the day, okay? So there is a method. What I'm about to throw at you is I will admit, rather diabolical, but there is a reason for it, and I want you to understand the reason. And it is very possible for you to cheat on this assignment, right? And I will never know. Well, I might know some of the ways you might cheat, but it's possible for you to cheat on this, get the same result without doing it the way I told you to do it. And if you choose to exercise that option, you are ultimately losing, because you will not actually learn this thing that I think is very important for you to know how to do. This part of AutoCAD that will never change, okay? So I know it's going to be frustrating, and I know you're going to feel like must be easier ways to do this, and there absolutely are easier ways to do this. And I promise I will teach you those easier ways, but I'm not going to teach them to you today. I'm going to teach you this hard way first, so that you can kind of like drill into your brain some fundamental concepts, so that then when we roll out some of these fancier interface tools, you will not only appreciate them, but you will also be able to contextualize them among some foundational concepts, which are very important. So the next thing any questions about that, by the way? Everybody okay? Got that? All right, suit up, because this is going to be tough. So we need to turn some stuff off, okay? Because AutoCAD defaults to trying to make your life easier, which is awfully nice of them, but for now, we need to not let them do that. So you see down here in the bottom right corner, these are called drawing aids. These represent various innovations to the application that have developed over the last many years. They've slowly added that make drawing in AutoCAD easier and leverage this graphical user interface and mouse and all that kind of stuff. So these are all very useful things, and we will turn all of them on very soon, because they are very cool and they make things a lot easier. But for now, we are going to turn them off so that we can understand what is actually going on here under the hood. So the first thing you want to turn off is, see this one that's like a circle with, looks like Pac-Man throwing up or something? And you hover over it and it says polar tracking. We're turning that off. Polar tracking is very useful, but we're not going to use it for now. This next one has a little plus sign and I don't know, whatever that thing is next to it. It's called dynamic input. Very useful, but not for now. We're turning that off, okay? You probably won't have show hide line weight turned on since we reset defaults, but make sure that's off as well. This one that says show hide transparency, you can leave that on or off. It doesn't really matter. It's not going to affect what we're going to do. Group selection, you can go ahead and leave that on. That's really not going to affect anything, but you're fine to turn it off too, but I would just leave it on for now. Object snap tracking, super useful, but not yet, okay? Object snap, also incredibly useful, but not yet, okay? This other one is show annotative objects. Like that, you can leave that on. It's not going to factor into what we're doing for now, okay? So make sure you have definitely turned off polar tracking, object snap tracking, and object snap. Oh, and dynamic input. Okay, everybody got those? Okay, so the first thing I want you to see now is you see this little thing here. Oops. This little XY thing on your screen. That is called the UCS, which I believe stands for Universal Coordinate System. AutoCAD is essentially a polar grid, of which you probably have had some experience with in some of your math classes that you've taken previously, an XY grid that you can graph things on, okay? That's all this is, okay? So X is the horizontal axis and Y is the vertical axis. And there has to be some sort of place here that we would call the origin that is 0 on the X and 0 on the Y, okay? And that we call that the origin. And that origin is this intersection of this green line, which represents Y, and the red line, which represents the x-axis. And then where they intersect is the origin, and that can be defined as 0 on the x and 0 on the y, or just 0, 0, which is how it gets defined in AutoCAD. You can just type that in, 0, 0, and that represents that spot where x and y intersect, okay? So to draw things in AutoCAD, you draw them relative to that spot. So if you're going to draw a line in AutoCAD, you say, I'm going to draw a line. And AutoCAD is going to ask you, okay, where do you want this line to start? And you're going to say, I want it to start at 0, 0. Means like start it at that intersection line. Okay, great. That's where it starts. Where do you want it to end? I want it to end at 15, 10, which means, okay, the other end of that line is going to, the spot in the grid will be 15 on the x and 10 on the y, and that you will have drawn a diagonal line. Okay? So that's how everything is drawn in AutoCAD. It's a coordinate system, and understanding that coordinate system is the foundational concept that you must understand in order to do absolutely anything in AutoCAD. Like, you cannot do anything at all in AutoCAD if you don't understand that XY coordinate system. And so part of the point of this assignment I'm going to give you is to drill that concept into your head, to understand that XY system and how this lays out, okay? Now, one of the things you will notice, if you kind of move your mouse around, you see over in the lower right corner next to all of those objects, those drawing aids, you see that those list of numbers that are changing. It's a list of 3 numbers separated by commas. The third one is 0 and it's not changing, but the first 2 are changing. That is X, Y, and Z for where your mouse is pointing right now in this grid system. Z is the axis we cannot see in this view because we are doing a 2-dimensional drawing, but Z would be vertical, okay? Z would be the axis that is, if it was possible for it to do so, would be jumping out of the screen towards you, okay? But we're not drawing in 3D, so you don't really have to worry about Z, but it does exist technically, but we're never gonna really use it for anything we're doing in our class. When you take the sound system design class, we will have to start thinking about Z a little bit when we start drawing 3-dimensional models of the theaters to do acoustic analysis on them. But for now, Just know that Z exists, but it's not going to be a major part of your life yet. But you can kind of see how this changes. So if I kind of start hovering over that origin point, I'm more or less at 0, 0. And as I drag my mouse right, you can see that that first number is getting larger. Right now I'm at 11.3604 because I've moved about 11 points in the positive direction on the x-axis. Now look what happens when I move my mouse to the left of that origin. Okay, that x value becomes negative. So I'm moving in the negative direction on that x-axis. So now I'm at negative 10. Okay, I go back to that origin, I move my mouse vertically, and you can see that the second number is now changing. So now I'm sitting at a little over 5 on the y-axis. And then if I go down, I get to negative numbers on the y. So now I'm at negative 5 on the y-axis. Okay, is that working for everybody? Does that make sense? All right. Now, here is a very important thing to understand about AutoCAD. AutoCAD does not draw scaled drawings. And those of you that have experience previously in either hand drafting or maybe other CAD drafting tools, the concept of scale has been very important. And so what scale means is, like, if you're gonna, in the olden times when we drew these with pencils on paper, you know, you were trying to capture an entire building on this tiny piece of paper. So the building might be 100 feet wide, but you're not going to find a 100-foot piece of paper to draw that on, are you? Right? You're gonna scale it. In other words, you're gonna say, all right, I got to make this drawing fit on this piece of paper, and therefore I'm gonna say for every 1/4 inch worth of space that I draw, that will represent 1 foot in real life. 1/4 inch equals a foot. Or for every 1/2 inch I draw, that represents a foot in real life. That's called scaling. And you can actually buy rulers that do this for you. That are already labeled in actual feet, but it's like everything on that rule that says that's 1 foot, 2 foot, 10 foot, 20 foot, it's actually representing 1/2 inches, okay? The cool thing about AutoCAD is they're like, yeah, that doesn't matter because we're drawing in digital space and that is theoretically infinite. So there's no need to think about scale because drawing a 100-foot line or a 10-foot line or a 10-inch line there's really no difference in the digital world. I mean, it's not like that 100-foot line takes up any more space, digital space. Like, it's still just a number that we have to save, and that number takes up no more data storage than a smaller line, right? It's the same, okay? So you don't have to think about scale. And that's something that AutoCAD has pretty much stuck with. They're like, yeah, we're not drawing in scale. You are drawing the full size and the actual size of this thing. The only time you start worrying about scale is when you have to start printing it on a piece of paper. At that point, you have to think about, okay, well, when I'm going to print it out of a printer and put it on a piece of paper, I have to shrink this down. But until then, you really don't have to worry about it. You draw everything in full scale. So AutoCAD is also what I would call unitless, meaning it does not, follow any conventions regarding units of measurement. So it is neutral in the whole metric versus the weird thing that we do here in America. It doesn't really take a stand on that. It just says, whatever. It's just a unit. It's a unit of measurement. I don't really care what it is. You draw in units. It's called AutoCAD units. Units of measurement. It's some sort of like generic unit of measurement that represents their XY coordinate system. And they take no particular stand on what that unit means. So when you draw a little line that starts at 1, 1, that's not necessarily 1 foot on the Y or on the X and 1 foot on the Y. That's just one AutoCAD unit to the positive x and one AutoCAD unit to the positive y. And you get to decide whether that unit represents a meter or a foot or an inch or, you know, or even a hectare or a parsec. Like, it can be whatever you want it to mean. Yes?
So when we do this for paperwork, do we have to set up a key specifying, like, this is what it means? Or
Maybe.
is there a rule for it?
Maybe you might need to do that. It just depends. The good news for us is that even when we make drawings that connect to physical space, no one's going to build the thing that you draw, right? When you have a ground plan or something, and you're going to show where speakers are going to go, no one has to build that building that is drawn. I mean, or that building's already been drawn. Someone else has already drawn that, and they drew it to scale, and an architect drew that, and a contractor built it. The scenery part of it, you know, a set designer drew, and a technical director like figured out how to build that and all that. So, you know, no one has to put a ruler on your piece of paper and turn that into something they can measure with a tape measure and cut a piece of wood. Okay, like that just doesn't have to happen for anything that you're ever going to draw. Okay, so being able to draw to specific scale on paper is really not something that we need to worry about a whole lot for what we do. We just need to kind of know, where does that thing go? We're going to put this thing in this room, and where is that? So very rarely in our world does that scale piece matter, but every once in a while it does, and if it does, then yes, you would need to say, hey, for every ½ inch on this piece of paper, that represents a foot in real life, okay? But very rarely in our world does that matter, okay? So you get to decide what the units mean, okay? And let me show you what the options are. Type the word units, U-N-I-T-S, and hit enter. It brings up this little window. And this is where you kind of tell AutoCAD what you want for this. Now, what I want you to see is, for length, you have an option for type. And if you click on that menu, you can do what's called architectural, decimal, engineering, fractional, and scientific. Again, notice they're not yet talking about feet or meters or anything. They're just like, what are you looking for? Decimal just means a generic decimal value, which is what it defaults to. Okay? If you go to architectural, that's where you end up with things like 1 foot, 3 2/16 inches. And that is exactly what you would type into the command line. And for some people, that's important. That is what they want. They want to be able to type in the exact thing that they would measure on their tape measure. Okay? That's not super helpful for us, but that's an option. Engineering is similar, but it keeps it in decimal. So you still type like 1 foot, 3 inches, but if it gets any more specific than that, it would be 1 foot, 3.25 inches, right? That would be engineering speak. Fractional is a fractional version of the AutoCAD generic units. So instead of saying 0.25 units, you say 0 units, 0 full units, but 1/4 of a full unit is what I will use, right? You would actually type that in. And you can specify kind of the precision of that. Scientific is where you type in scientific notation. I don't know who that makes sense to, but it must make sense to somebody because they put it in here. The one that you're going to live in mostly for what we do is decimal. And that's because we're sound people and we have to do a lot of math, but we tend to not like math. And we really don't like math that involves numbers that have more than 3 digits. And we will go to extraordinary lengths to avoid having to deal with numbers that have more than 3 digits in them. And dealing with fractions tends to intimidate a lot of sound people. And it actually doesn't translate very well into the kinds of things we really have to measure and do. And so we tend to, and most of the other tools that we utilize tend to deal with decimal values. Okay, so we are going to work in decimal for pretty much everything we do. And whenever you get a drawing from somebody else, like when you get a drawing from the technical director, it's probably going to be in architectural style, because that makes sense to them, because they want to be able to write whatever they can measure on their tape measure. And you're going to have to convert that back to decimal in order for you to be able to work with it. And we'll get into that later. So you want to do decimal, and precision. I would tend to knock that down to 3 decimal places, because again, we're sound people and we don't like numbers that have more than 3 digits in them. So there's very few things in our life that need to be any more precise than that. And then you can get into like degrees and things. Again, decimal degrees is where we want to be. How precise? We very rarely need to worry about decimal value degrees, so just keep that at 0. The only place where the actual unit becomes important is what's called insertion scale units. And that means like if you have another AutoCAD drawing that exists and you are going to like import that into your drawing, remember AutoCAD is unitless. So that file was drawn as just generic AutoCAD units. But whoever drew that drawing had made some decision about what a unit meant to them. And when they drew a line that was 1 unit long, that meant something to them. And it might have meant an inch, it might have meant a foot, it might have meant a meter, it might have meant a parsec. And you just need to ask them. When you get a file from somebody else and you want to import that into your drawing, you say, hey, what do your units mean? And they will say, they mean this. And if they say, I don't know, then you say, well, we got to find out because I got to pull this in. And so here are your options. Unitless, which is like, I don't know, that's just AutoCAD units, doesn't matter. Inches, feet, miles, millimeters, centimeters, so on and so forth, nanometers, angstroms, I don't even know what that is. What is an angstrom? Decameters, light years. Look, there's parsecs, survey miles. So it's just whatever. It's all the same, right? It's still just AutoCAD units, but this is like, if I import a drawing into this, what should those units represent, okay?
An angstrom is 100 millionth of a centimeter.
Sorry, what now?
100 millionth of a centimeter.
It seems like it says it's used mainly to express wavelengths and interatomic distances. It's mostly a chemistry term.
Okay, well there you go.
Why are we drawing that stuff again?
If you're doing a chemistry drawing, you might
So here's the thing, you can set this to anything you want and it doesn't change what you do. Okay? It doesn't change anything for you when you actually draw stuff. This only comes into play when you import one drawing that exists into here. That's when this value becomes important. But if you're never going to do that, which we are not going to do for this assignment, then what you select here doesn't mean anything. It's nothing. It's irrelevant, okay? But I just wanted to point that out. Okay, so there you go. Hopefully your units are set to decimal. I would suggest a 3 decimal place precision, and then just click OK. So now what you'll see is, now these numbers on the bottom right are now just doing that slightly lower precision of 3 decimal places, which is maybe helpful. Okay, everybody with me so far? We good? All right, let's draw something. So if we go back and look at this assignment, what if I want to draw this symbol, this generic device block symbol? Well, to draw this, I got to kind of like look at it and break it down into some X, Y coordinate system, and I have to have a strategy for that. But I also have to break it down into its component parts. And part of the instructions is you are going to draw all of this stuff using only 3 commands. There's a command called line, a command called rectangle, and a command called circle. And they do what you think they do. So the line command draws a straight line, the rectangle command draws a rectangle, and the circle command draws a circle. And so you're going to draw this whole thing using those 3 commands. So you have to look at each of these symbols and break them down into lines, rectangles, and circles. Okay? So this first one, okay, I see one big rectangle here. Okay, that's a rectangle. And everything else is lines. So I have this big rectangle here, and then I have a line there, a line there, a line there, a line there, and a line there. So I have 1 rectangle and 5 lines. Okay? And we have to draw this thing. This is just a symbol. It has no meaning in real life. It's not representing a real thing. I mean, it represents it, but it's not meant to depict it. So the size here is arbitrary. You just need to decide. And I look at this and I go, okay, well, this rectangle is maybe a little more than twice as wide as it is tall. So I'm going to say, if I were to break this down into units, I could say, all right, this is probably 25 units across and 10 units up. And the reason I could also just say it's 1 unit tall and 2.5 units wide. I could do that too, but then to draw these other lines, I'm going to have to get into really scary decimal values to figure out those other things. So it's easier. Again, we're sound people. We like easy numbers. And so I'm going to just draw this as 25 units wide and 10 units tall so that I can figure out these other lines without having to resort to calculating decimal values. Okay? So, all right, let's do it. I'm going to draw that rectangle first. So let's go back over to AutoCAD. And we're going to type the command rectangle. So literally type REC. The command is actually RECTANG, rectang. But you can just type REC, and that's an abbreviation. Just REC and then enter. And down there at the bottom, it says, okay, we have now entered the rectang command. Specify the first corner point. Or there are some other options here called chamfer, elevation, fillet is what's called, thickness and width. Okay, we don't care about any of those things. We just need to know the first corner point. So what's the first corner point? Well, I'm going to keep this easy for now, and I'm going to say it starts at 0, 0. So just type 0, 0, and this rectangle is going to start at the origin. So 0, 0, enter. Great. Okay, it's begun to draw the rectangle. Now it says specify the other corner. And the other corner is the opposite corner, the diagonal corner to that. Where is that other corner? That corner is going to be at 25, 10. 25 on the X, 10 on the Y. So 25, 10, enter. Ta-da! And it exits the command. Did that work?
Mine not that big, but yeah.
So yeah, if it's not that big on the screen, that's just a zoom thing. You can scroll with your mouse and get that bigger. Okay? There you go. We did it. We just drew something on AutoCAD. Woo! Okay. All right. Now I got to draw some lines. All right. The next line I want to draw is this long horizontal line for this title bar area. I'm going to say that line is 2 units down from the top. I'm just kind of guessing here, just based on what it looks like. If this is 10 units tall, then that line starts about 10 units down from the top. Again, doesn't really matter. It just needs to look like this. Okay? So take a guess and draw the line, and if it doesn't look like it's in the right place, just delete it and try some other spot, right? Okay? Don't worry about it. Don't stress about it. All right, so I'm going to say, all right, that is 2 units down. Cool. So I'm going to draw a line. So we're going to type L-I-N-E, which is the line command. Or you can just do L. L is the abbreviated version for the line command. So L, enter.
So if I click the line under draw, is that...
That's cheating.
Okay.
That is cheating. Don't do that. We're going to type. Okay? So type line, or L, and hit enter.
Cool, yeah.
And it says line. In other words, we have entered the line command. Specify the first point. Where is the first point? Where does this line begin? Well, this line, if this line is 2 units down for the top, then that would be 0, 8. So type 0, 8. Enter. And it starts 2 units down from the left side. And it says, okay, specify the next point. Well, this thing is 25 units wide, isn't it? Because we know that because we drew it. So it's 25 units wide. Therefore, the next point would be 25, 8. Enter. And it says, specify the next point. Or you can undo. If that line didn't end up where you wanted it to, you can type undo, enter, and it will go back to that where you were before, which is finding that next point. But it's fine. So it's saying, okay, it assumes you want to draw another line that picks up where this line ended off. But that's not what we want to do. And therefore, if we just hit enter without specifying a coordinate, it says, okay, you're done. You must be done then.
Yeah.
Okay, there you go. We drew a line. All right. Let's look at, okay, I got 4 more lines to draw. So I'm going to say that this line is another 2 units down from that last line. So now I'm 4 units down over here. And I'm just going to say this is a 2 unit wide line. So this is going to start at 0, what? 0, 6 is where it'll start. And it will end at
It would be negative something.
yeah, it would be negative something. Negative what? Negative 2, right? I said I wanted to draw 2 unit lines. So it'll end up at negative 2, comma.
No. Okay.
Where did we start? We started at 6, right?
Okay.
So negative 2, 6. You got it. Okay. So L, enter. We're going to start at 0, 6. And we are going to end at negative 2, 6. Enter. And then enter.
Good job.
Da, 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 da. Okay, that next line is going to be 2 more units down, so that's going to be 4 on the y-axis. So this is going to be L, enter. This line is going to start at 0, 4, and it will end at where?
Negative 2,
Comma 4, because we started at 4, right?
Oh, 'cause that's what we, okay.
Yep. Okay, now I look at that, and that's fine. I could live with that. I go back to my other symbol, and it's like, okay, well, they're kind of spaced out a little bit more there. So maybe it's farther down than I thought. So I'm going to type undo, and it says, how far back do you want to go? Do you want to go 1 step back, 2 steps back? You know, I'm just going to say 1. Just undo the last command. The last command was drawing that line. Okay, it's gone. See, I didn't even have to use my mouse. I just typed undo, go back 1 step, and I'm going to try this again. So I'm going to move a little farther down. So instead of 4, I'm going to go to 3 on the Y. Let's just see how that looks. So L, enter, 0, 3. And then minus 2, 3. And then enter. That looks better. I like that. I can live with that. All right, we're almost done. So let's draw the 2 lines over here on the side. So where on the Y was this line? Do you remember?
0, 6.
Yeah. So we'll start typing that. We'll go L, enter. So it will be 25, 6, because 25 is the end of this, right? So 25, 6. Okay, and where would the other end of that line be?
27, 6.
Yep, 27, 6. Enter. Got it. All right, 1 more line. L, enter. Where's this one? Somebody over here on the left tell me. Where does this next one start? The one that's down here.
It's 24, 3, or 25, 3.
Yes, 25, 3. And where does it end?
27,
Yep, 27, 3. We did it. Look at that. That's how you drew an AutoCAD in 1980.
That's so great. Fancy etch a sketch.
Yep, it is. It's very cool. Okay, so I want to show you the circle command really quick. Even though the circle command is not part of this symbol, let's pretend like I want to draw a little circle right there at the end of that line to represent like an audio splice or something. So I want a circle centered at that point. So I'm going to type C, enter for circle. Or you can just type the word circle, C. And it says, specify the center point. So what is the point at the end of that line? Where is that? 27, 6. Okay, it has started a circle. Now, specify the radius of the circle. How big do you want this circle to be, radius-wise? 1 would be pretty big, right? Like if I type a 1, that's a pretty big circle. Okay, so I'm going to undo that. I want it to be a little bit smaller than that. So let's try that again. 27, 6. And I'm going to say, I want it to be quite a bit smaller. So I'm going to say 0.25, quarter of a unit. We want a tiny little circle at the end of here. Enter. There you go. And that's how you would do, like you see this one here where you have to do that little circle inside of there. That's how you would do that. Okay. I have now shown you everything you need to know to complete this assignment.
Why, thank you, Jason.
You can draw this entire thing using everything I have just told you. Okay? There are a couple of gotchas here that I want you to watch out for. Kirsten's over there going, what about the triangle? I said, yes, there are triangles here. And I have not taught you how to draw a triangle, have I?
It's just
A triangle is just 3 lines, isn't it? Okay, so you got to figure out how to draw an equilateral triangle using 3 line commands. When you get to that part and you get stuck on it, ask me for help and I will give you a hint. Here is a little equilateral triangle calculator. And if I just type a 1 for how long these sides are, you are going to need to know that h value, which is that height value. And that h value is 0.866 of whatever the length of the triangle is. That's your secret. That's your secret number, your magic number for drawing an equilateral triangle with 3 lines. 0.866. So when you get to that part, see if you can figure out how to use that 0.866 to get you that line.
Oh.
Okay? That's just, don't worry about that yet. You're not there yet. But when you get there, I wanted to have, at least for you to have a hint. Okay? So that's all I'm gonna say for now. Start working on this. See how far you can get. Okay? Ultimately, you have by next Monday, you need to have this done. They don't necessarily need to be perfectly laid out like this. I don't really care about that. I just want each of these symbols drawn, okay, like this. As close as possible to how these look, okay? And then, depending on who you are, you will either also draw this or you will draw this, okay? And you can do that all in the same file if you want. Or if you want to do it as separate files, that's fine. So once you are ready to, let me just show you how to save really quick. So you are going to, if you want to use the mouse for the saving, I'll let you. So you can go File, Save, and you have to put this somewhere. Mine's defaulting to Documents, which is fine. So I will just do Assignment 1, Symbols. Okay, and hit enter. Okay, and then you could make a new drawing using that AutoCAD DWT and start from a blank canvas here to draw the other thing if you want. Or if you want to do it all in one drawing, that's fine too. But if you do it as 2 files, you just have to upload both files to Canvas, okay? So start working, save often. Remember, don't cheat. You can do this without ever touching your mouse. It is possible, okay?
Do you
Yes.
consider it cheating by using the mouse to move it to see the coordinates? Like, so I don't have to do the math, I could just put it there and see.
You have found the one cheat that I will allow. Yes.
Shit.
I was waiting for someone to find that.
I suppose the move tool is also disallowed.
I have not taught you the move tool, have I? So,
Italian, but you have not.
I have not. You must only use the commands I have taught you.
Oh,
So, by the way, I want to review for you, this will be your first assignment in this class that I will grade for you, and I want you to understand how I am going to grade it. So, let me show you the little rubric that I use, okay, for this, so you know what's important to me. Let's see. I think that's it. Yes, it is. Okay. So I care about 3 things. I care about the degree of completion. How complete is this? Did you do all the things? Okay? I am interested in the quality of your work. And I'm defining quality as how many errors are there? How many mistakes are there? You know, the highest possible quality would be no mistakes. Okay? And then I care about your mastery of the critical skills. In other words, did you do it the way I asked you to do it? Did you learn the skills I wanted you to learn? And the way that you would demonstrate that is by following my instructions with exactness. Do it the way I said to do it. It is possible to complete this assignment using methods that are different from what I said. And if you choose to do that, that will mean you did not master the critical skills. And therefore, I will be less enthusiastic about that work, okay? So those are the 3 things I care about. Is it complete? Are there mistakes? And did you do it the way I asked you to do it? Okay? Yes?
Are we gonna upload this as like a PDF or
As the DWG file.
Okay, is that something we need to like zip before you?
AutoCAD or Canvas seems to be able to deal with those DWG files, okay? So just keep that in mind. Those are the things I care about. If you want to get a good grade, that's what I want you to do. Do all of it. Try to catch all your mistakes and do it the way I said. Don't do it differently than the way I said. And I actually will probably know if you did it differently, because there are clues that I will be able to spot that will say there is no possible way you could have drawn that line that way in that spot through typing, because you drew a line that was like at X of 2.7835. I'm going, yeah, you would not have typed that. You would not have figured that out with your pencil and typed that number. You would have done that with your mouse, right? So nice, simple whole numbers is probably where you're going to end up with. The only place where you're probably going to end up with that 3 decimal point precision, it might be on the triangle. But other than that, everything's going to be pretty simple lines and numbers. Okay? So start working. When you get stuck, ask for help, and I will gladly help you.